where's my, oh, there it is. Well, we only have something to talk about. We were at, where were we? Type check and cast. Maybe. Ranges, yeah, we have traveled ranges already. Type check and cast. Yeah, this is something that we should probably. Alright, everyone, welcome back to Learning Kotlin live and this is the episode 42 of it. So, basically, live, yeah, in even episodes, we look at the documents, we read the documents, and here we are. Type check and cast is and s. Well, is and not is. This is so straightforward, pretty straightforward. Object is string, so this is just the type check. If object is an implementation of string or is a subclass of string. If object not is, well, this is not, or you can maybe read it as is not. Well, that's still straightforward. Smart cast. Okay, this is something that is smart, really smart, that Kotlin have done. So if there is if blah is string, just like some sort of try catch block, or let me think of it. I don't know, but yeah, this is an example of what is it? It's just like the early return, but in a different way, probably. So if x is string, you can print x.length, and here we know there's a length property because x is automatically casted into a string. And furthermore, well, where am I? I'm smart enough to know cast. So even if there is an earlier return, just like I have mentioned, it can't directly be used as string after this not is syntax. And yeah, because of the short circuit, how do I explain it? So for compound statement, if x not is string, because for OR statements, any of it is true is with one true, we can imply the whole statement would be true. So if this will only happen when this is not true. So here with x not is string, or we know that x is string here. So this is also the same, alike in AND statements. If x is a string, only when x is a string we will evaluate this, so we can directly use it as string at after a x is string statement, or after a x is string AND statement, or after a x not a string OR statement. So SmartCast can work well with when expressions and while loops. So sort of like while x is string, and if you assign it into some other things, I don't know, but you can work it with while loops. So for when expressions, you can use when x and is blah blah, is blah blah, is blah blah. Oh, this is so smart. SmartCasts do not work when a compiler cannot guarantee that a variable cannot change between the check and the usage. Only for value local variables. For value local variables, this means immutable local variables. only except for delegated properties, we can, oh, we haven't talked about delegated yet. Let's see where it is. It's in somewhere in, oh, okay. Maybe I should have read it earlier then. It's right after inline classes. And yeah, this is something I skipped. I should have talked about it. Okay, so this is something that we will definitely talk about in our future episodes, but well, we can only skip here now then. So value properties, if the property is private or internal, or the check is performed in the same module where the property is declared, this is when we can utilize SmartCast. So for open properties or properties that have custom getters, or when a property is accessed outside of the block where it is declared, you can't use SmartCast because it is subject to change. Well, interesting. And for mutable variables, if the variable is not modified between the check and the usage, and it is not captured in the lambda that modifies it, and is not local delegated. Okay, it works like, and as long as you don't change it, that's it. And for var properties, you can never expect a SmartCast because the variable can be modified at any time by other code. Makes sense, probably. Really? Can you still SmartCast it in the same block? Well, if it says no, then probably no. Where is a safe cast? Okay. A SmartCast itself, or a checked SmartCast is safe. And if you are just darn sure that you don't need that if check, then you can use unsafe cast operator because it is unchecked, so it is unsafe. So note that no cannot be cast to string as this type is not nullable. Oh, well, that's what it is defined in Kotlin. If y is null, the code above throws an exception. Yeah. So whenever you can, you use the SmartCast or check the cast. In order to match Java cast semantics, we have nullable type at cast right hand side like Oh, and there is a safe cast operator. Oh, okay. This is just when you add a question mark after that ask, then if it is null, it will not throw an exception. You would simply return a null. Type erasure. Okay, this is a little bit hard, I guess. Kotlin ensures type safety of operators involving generics at compile time, while at runtime instance of generic types hold no information about their actual type arguments. Well, this is just by the design of Java. For example, list foo is erased to you just list star in general. There is no way to check whether an instance belongs to a generic type with certain type arguments at runtime. Given that a compiler prohibits is check that cannot be performed at runtime due to type erasure. generics. I've already read this. Why am I so unfamiliar to it? Sometimes you want to say that you know nothing about the type argument but still want to use it in a safe way. Well, so it's neither in, neither out. Then with a start projection, it's probably a wildcard to anything. The safe way here is to define such a projection of the generic type that on every concrete instantiation of that generic would be a subtype of that projection. Yeah. For foo out t upper, t is a covariant type parameter with the upper bound t upper. Foo star is equivalent to both foo t upper and is there no lower? No? Okay, I'm understanding it incorrectly. Means that when the t is on down, you can safely read. How about right? Oh, okay. So, okay. Because we don't know anything, so you can only read from it. You can't write to it. Huh? Oh, okay. So this is for a type for generic, which is neither neither out nor in, neither covariant nor contravariant. So this is both. That's also expected. So if a generic type has several type parameters, each of them can be projected independently. Actually, I'm not sure if I really know what the Java row types means. Let me take a look. Ah, there it is. If you don't declare any strange class, where is it? Here it is. This is probably a row type. I'm not going to take some time to verify if I'm correct. So just let me know if you feel like it's incorrect. Well, we're going to visit delegation someday. Not today. So here we are. If something is list of star, and then we will type this. If we try to read the items of a list of star, then the item is always typed as unknowable any. So similarly, if you want to write, if you already have the type arguments of an instance checked statically, wow, this is a little bit hard, definitely. This is something that is checked runtime, probably, and this is something that is checked compile time at compile time. I believe that is the idea behind this, but they are just something that I don't quite get it. The same syntax with omitted type arguments can be used for casts that do not take type arguments into account. List has array list. Inline functions with verified type parameters. I never understand this. Verified, where is it? Where is it? If you want a type, class type. Okay, I'm going to skip it. Okay, this is a little bit hard for me. Inline functions with verified type parameters have their actual type arguments inline at each call side, which enables arg is t checks for the type arguments. Verified A, verified B, which means oh, okay, because it's an inline function, so it is going to be converted into the possible implementation at runtime, at compile time. So if you are using it as a pair of any or and any, then there will be an implementation or a interpret, or how do I say it? Wow, there will be a copy of code, a copy of this code fragment, which is you have the any type, the any question mark, replacing these a b here. With that, it is type safe. Arg is t checks. So we know that this is a string as pair of any and any. Break type safety. But if an arg is an instance of a generic type, it is erased, so it breaks the type safetyness. So you can, the only place that you can use it in a generic type is list of star. What is it? What's the name of it again? The star projected type. Okay, I kind of feel like I don't know exactly what I'm talking about, but I hope whoever is listening to it listening to me can understand it. Hopefully, that would be a miracle. Unchecked test. As said above, type erasure makes checking actual types of a generic type instance impossible. Yeah, that's type erasure at runtime, and generic types in the code might be connected to each other not closely enough for the compiler to ensure type safety. Even so, sometimes we had high-level program logic that implies type safety instead. For example, read dictionary file, we read a file from it, and it will return a map of string and anything, start projected type. The compiler produces a warning for the cast in the last line. Unchecked cast map of string of okay, to map of string of integer is unchecked. Well, from the read dictionary, we don't know anything about what this dictionary is going to be implemented. That's definitely, yeah, unchecked. Yeah, it provides no guarantee. I have a document reader and a dictionary writer with type-safe implementation for different types. Use reasonable abstractions to move unchecked cast from calling code to the implementation details. For use of generic variants, probably the covariant and contravariant. For generic functions, using a reified type parameters make the cast such as, but it's not inline. Makes the cast such as argst check. Aha. What is this 2 here? Anyway, this is just trying to use a generic type, this star or this A and B here, and you can use it as a safe. Actually, you're not using it in a generic, is it? Yeah, it's not a generic type actually. But anyway, it is, you can know the type, you can have it checked. Make the cast such as argst checked. Unless args type has its own, unless this one is a generic itself and it get erased. And unchecked cast warning can be suppressed by annotating the statement suppress unchecked cast. On the JVM, the array types retain their information about the erase type of their elements, and the typecasts to an array type are partially checked. Okay, this is new to me. The nullability and actual type arguments of the elements type are still erased. For example, the cast foo as array list of string nullable will succeed if foo in an array holding any list of star nullable or not. I don't quite get what this line's trying to talk about. Wow, this is a lot to me. I need to reread this part again and again probably. So yeah, we're approaching the end of this lesson, so let's have a really quick recap on what covariant and contravariants are, and if you're interested, they are covered in my let me see, 30? Can't remember. Well, it's there covered in my episode 26, generics. And It's just like the extend generic wildcard and Java and super wildcard. And the purpose of these extends bounds and upper bounds are to provide type safety. So if there is a covariant relationship where C is covariant in a parameter T, or if there is a, where is it? Where is the C? Um, um, okay. Here we are declaring source out T, which means that source is covariant in the parameter T, and this means that source out T can be a producer but not a consumer. So it is okay with this out parameter there where you can assign subtypes of source of strings to this object. Because we'll only use it as a producer of T. So T will only show up in the return type of the function, and that's the meaning of this out, declaring that we are this interface or this class is maybe only interface, I guess. This interface or is never going to take or consume a T. So with that, we can always safely assign source parent of a class. We can always assign source a subtype to a source of type. So comparable and no, it's not about comparable, but this in relationship here is just the opposite, where we can have a consumer function of a T, which means we are using the parameter T in the we're using the type T in the parameters, but not in the return types. With this, it is guaranteed that we can always call one of the functions with the T, with any T, as long as this T is a subtype of the declared item here. So for instance, for comparable number, you can always call x.compare to a subtype of number. You can also use y comparable a subtype of number, which for this case a double as well. So let's get back to the star projections. So for foo out t upper, because the t upper relationship is unknown here because of type erasure. Is it because of type erasure? And let's see how is it used here. No, this is reified, but this is okay. This is type erasure. So this is just talking about there is no way to check of it at runtime, because if you want to check something as list of star, well, it is always true, but prohibits is checks that cannot be performed at runtime due to type erasure. So you cannot use like something is list of string, nope, because the string is erased here, but you can still check if something is list of something. Something is list of star, where you still check if it is a list, but you can't check if it is a list of generic any implementation. So when you already have the type arguments of an instance, check statically. Because we already know this is a list of string, because this is what the signature says, we can still check if list is arrayed list. You can check against the non-generic part. You don't need to check if it is a string, because you already know it in this case. But so you can still check if list is array list. So likewise, this is just like you can still check list is array list of star for this case or this case, either way. So this is just talking about you need to omit the angle brackets. So for rarefied, I am never familiar with rarefied, so I'm not going to reread this part, but I kinda get the feeling of it. Just rewind to what I've just said if you still don't get it. And if I am not expressing it clearly enough, just let me know. So as said, type erasure, make check actual type arguments of a generic impossible. Even so, we have high-level program logic that implies so. So you can avoid unchecked cast by designing it with the variants, or we can also utilize the rarefied type arguments. And when we have no, this is the last resort that we can use, is to suppress the warning, where we are just so confident that this you can omit this unchecked cast warning. It's not going to happen. If you're sure about that, you can use this suppress on typecast. And let's see. On the JVM, the array types retain the information about the erase type of their elements, and the typecast to an array type are partially checked. The nullability and actual type arguments of the elements are still erased. Huh? Why? Array of list of string, because the array is special in JVM. And because of so, we can check this list of star here, but we can check if it is array of something here. Wow, this is just, I still don't get it. Let me know if you know how I can explain it clearly. So that's probably all of it. We will see you tomorrow at another coding practice. Bye bye.